Okay, before I begin, I'm just going to remark that I have in the background a lookup tables where I have the decimal, the binary, the hexadecimal, and the octal numbers all written out and equivalent to each other. Also, I have the binary rewritten with four digits on the last column there. That is to correspond to hexadecimal. Now, if you're doing a question, it's sort of handy in your exam paper to have something like this ready. Probably not to this level of detail, but just shows your workings. Now, I'm going to refer to this, but I won't be sort of crisscrossing back to this table here. So I have everything written out, but if you just want to set up your own sort of tables like something similar to this, you'll find that you should be able to follow along fairly quickly. So I'm going to answer four questions, and the questions all pertain to the. Let's just sort of spread that out there a little bit. So convert the following hexadecimal numbers to binary or binary and octal. So that was the last one there. So we have four hexadecimal numbers, and what we have to do is convert them to binary and octal. So we have the first one here is C9, okay, to the base 16, okay. So what I'm going to do there is let that equal to, or just rewrite that out using my lookup tables. C corresponds to 1100 and 9 corresponds to 1001. So that's the binary equivalent of C9 for that in binary. Now you notice I have it written out there in groups of 4. Actually, that's the way I have it sort of set up in my tables. But what I'm going to do here is regroup them from the left-hand side into groups of 3. Okay, so I have the first 3 are 001, so that's my first group. Okay, from the right-hand side even. Then I have 001, that's my second group. And then I have 1, 1. So I'm going to rewrite that as 0, 1, 1. Okay, and that is my third group of 3. Okay, and essentially what I'm going to do here is, again, use my tables to look up the corresponding octal numbers to these sets of 3 binary digits. I'll just actually go back very quickly. So in this case, we have, you can ignore the first 0 here and just look at the 3 digits starting from the right hand side. Okay, 001 and 011. Okay, so that's what. So essentially, that corresponds to 3, 3, and 1. Okay, 011 and so on. Okay, sorry, that should be a 1 there. Okay, and so C9 to the base 16 should equal to 331. 311 to the base 8. Okay, not off to a good start here. So essentially the second one is as follows. Convert the following hexadecimal number to binary and octal. So same again. F0 to the base 16. So the binary number that corresponds to F is 1111. 0, the binary number that corresponds to 0. And again, we're going to use 4 decimal places here. 0, 0, 0, 0. Okay? So that's the binary equivalent of hexadecimal number F0. Now, again, it's split up into groups of 4. So what I'm going to do is, from the right-hand side, regroup it into groups of 3, and then find the corresponding octal number for each group. So from the right-hand side, the first group is 000, then 110, and then finally 11, and I'm going to put a preceding 0 in front of that. Okay, so looking that up, get from my tables, I would get 360. So F16 to the base 16, sorry, F0 to the base 16, that's 0 there, is equal to 360 to the base 8. Okay, so we'll do 2 more. AB to the base 16, so the binary number equivalent of A is 1010. The binary equivalent of B is 1011. Splitting them into groups of 3, starting from the right hand side. 011, okay. Then 101, that's the next 3. 101. And then we have 10 left, so we put a preceding 0 in front of that. Okay. and then get the octal equivalents. So we get 0, 1, 0, that in octal numbers that is 2, 1, 0, 1, octal 5, 1, 0, 1, 1, octal 3. Okay, so AB to the base 16 is equal to 253 to the base 8. So one more and we'll leave it there. A little bit longer this time. We have 3 digits here, A65. So that's in the thousands in decimal numbers, probably 2,500 and something. So A is 1010, 6 is 0110, and 5 is 0101. Okay? So, and again, breaking it up into groups of 3, starting from the right hand side. 101, okay. Then we have 100 here, 011, 001, okay. And then finally 101, okay. And that corresponds to 5145 in octal numbers. So that is our last one there. Okay, that's it. So just actually the important thing here is when you are working with hexadecimal numbers and you're looking for the binary equivalent or something like that, or some sort of conversion, it is best to actually work, you have to work with the 4-digit equivalent, okay, so including all the leading zeros, okay. This is very simplistic to start out with, don't use those. Okay, just use the correct number of digits, okay, to base 16. Okay, we'll leave it there.